through the information. Those things will see it's before I talk about it. So there's no way to have it in so OTbase does the reason why is there's no way to get a context. So if you have a question about this, and change. So what we're looking at here is the inventory portion. Right now, it's called fast analysis. I'm going to change the scale and look at one set, one location. I'll change my location. First thing you notice is what's the charts. And these charts are going to so is all this so is this just physical inventory? Physical and there's a virtual as well. So okay, so it can be software. And I'll get to that software. Okay, it's part of okay, great. So if we go through this, there's a code system. Anything in gray is not blue. So let's just scroll down. Next to those keys. So the first thing you notice is there is bottom of customers is
yeah, it's not. Are you going to the modification? Okay.
Are you like? So that's everything is automatically discovered. What is automatically discovered is the data. It's life cycle. The serial number is the after all the was catalog description. You can also see the slots which occupy that. They're bigger. Firmly, serial. Notice they're all orange is so horizontal. So not only you can have really good sheets that makes a PLC. We'll get to networks here in a second. By comparing it with the so in other words, we are older. So in that case, we decided to cut front books. It's flat. Okay. Then you also have a diagram. All diagrams are based on this. So if this configuration is different, this PLC will plug to a different switch. That will be reflected here as well. It's the scope. So things like topology maps.
Is that done for like decaf or?
So it's a combination of the different protocols. Two of the protocols. Right. You can also see here the firmware version, the base firmware of the PLCs. Also, taking it. See right now, there's no screen. There are those. See, very scoring series published. There is no release for the and there's a script. And you're just pulling that straight from Stuxnet and it's
Here's your links, including your ICSA certificate. But most importantly, where the damn devices are in the first place. So if you're looking here, back to my flat rock example, I have 8 of these devices that have this particular vulnerability. So think of it in, you get a service, a note from one of the suppliers, vendors saying, hey, you need to update this firmware version to so-and-so because it fixes some critical flaw. The problem you have without a comprehensive inventory is, okay, where is it? How many do I have? Does it affect anything critical? Is it critical to the installation at all? You don't know those things because you don't have an inventory to tell you. So you end up spending so much time trying to figure out. And a lot of places don't even do it because they can't. So quickly you can see here. And then if once you decide to mitigate this and patch it, it'll show fixed here as well. Right?
Now, does it just all list or?
It actually will show fixed. Right? So any questions in the PLC? All right, let's go to the next device type. Let's do system.
Would that just be? So we rule for last type one brand. So we don't deal with PLCs. So would it be cool if like we give you kind of an overview of like what we do?
absolutely.
And then we can tailor this kind to
Absolutely. So after I finish this, let's pull to the side. Let's have that conversation and see if we can see if it doesn't work for you. Okay. All right. So now we're looking at a switch. This is an L2 switch, Cisco. Once again, the map has been uploaded and used discovery information to populate the location. But you notice this particular switch is giving criticality to the business continuity line. So you're able to attach criticality to devices, processes, and systems. Right. So here's your discovered information. You have your vendor model, version, type, and you notice here, this device is phased out. So this ties into your obsolescence management as well. Serial number, CPE, catalog description. But in the case of a switch, you have your entire port list here. Your port list, negotiated speed, and what it's connected to. And anything in OTbase is underlined, you can get more information about. So if you want to know what this device right here is, click on it. And this device is a VM, personal virtual machine. Right, and there's an information about their virtual machine. So the breadth of knowledge here is you have your virtual machine. It's a Windows 7 service pack, end of life. And you mentioned so on this Windows machine, software piece is installed. All the software and the version of that software is installed, inventoried as well, because that plays a key part in vulnerability management. All right. Then also any patching that was done and what patches were installed. Okay. Well, if we jump down into security, you'll see here that it does have some security software installed up here, as well as a histogram showing you the last time it was patched. And this was in 2018, and 24 patches were installed. So you go to your vulnerabilities. So by default, we're always looking at the ones that vulnerabilities that can be exploited, your KEVs, your known exploited vulnerabilities. Those are the worst of the worst. But, and there's 171 on this particular device, just one device. But if you uncheck this, you'll see how big the problem really is. If I can uncheck it. Come on. It just says, this is no. Well, we'll go into some, maybe the internet issue here. There we go. You'll see it had 171 known exploitable vulnerabilities, but total vulnerability is 4,900. So huge problem that cannot be fixed by patching alone. But if you jump into your vulnerability profiles here, you see anything in orange has a known exploit, right? So let's grab a Windows vulnerability. That's one right here. Right, there's your criticality, your base score. Again, there you go. Your description, your links, and you'll notice here the remediation. So the patches necessary to remediate are linked here as well. But even more important than that is which devices have the vulnerability and where they're at once again. And you can also show the percentage fixed here as well. So if there are any that have been patched, you'll be reported back here saying it's been fixed, and it'll be in blue. Look like you have a question.
Yeah, so CVEs are kind of ubiquitous, right? So let's say that you have a CVE, right? But for us, so we're in the rail industry and we're actually a locomotive manufacturer. So some CVEs, like this is a 9.9, right? But really, if you add in the temporal environmental scores to the CVE, that might drop down to a 4 or 5. So is there a way here to change that, or?
Let me show you that. We're deviating from asset part into vulnerability management, but I'll show you exactly what I'm talking about there.
And while you're doing that, is this sold in modules, or?
It's all together. It's one. There's no modulation. The only add-ons would be your connectors for Splunk powered by ServiceNow or the advanced report writing. But everything you see here is part of it. It's not modular. Okay. So what you're talking about is, let's say you wanted to change the severity of a particular vulnerability. You're saying, hey, it's not as relevant. I need to change it, or part of the devices affected by it are air gapped or whatever. Exactly. You want to modify that. So you do have the ability to do that right here to modify the CVE. So you can come here and change the relevance to criticality, and then you see where it says affected devices. You can actually come in here and turn off devices that aren't affected and give reasoning behind it. Oh, this is air gapped. There's a firewall here, or there's no need to remediate this one. So you do have the ability to change that as well. Per CVE, per device as well.
Yeah, that's becoming more and more important with like the CRA.
We lost it. Let's go back here. Let's see if we can get back in there. Give me 1 second here. Crash dummy. Yep, I'll just go back in. 1 second. It's that good hotel Wi-Fi. Taking a second to log back in. So once we jump back in, I will go ahead and show you, because we've got a couple of device types already. I'll show you the software portion. Then we'll jump into network inventory as well.
So device, I see a lot of this is IP based. You guys also pull from like architect. Right.
Okay. There we go. I think we're back in it. Really slow today. But I think what you're asking, the discovery portion is soliciting the devices in their native protocols. Right. So that's where we're pulling the information from the devices. Now you could import directly into here, bypassing discovery if you needed to. But in order to get a comprehensive inventory, you need to be constantly, it's once every 24 hours, it's not a continuous scan, but you need to keep that up all the time for the vulnerability management. So let's go into the, absolutely, absolutely. So now we're looking into software. So all software and all versions of software inventoried as well. So you can quickly come in here and say, I wonder how many versions or how many instances I have of this Microsoft Help Viewer and what vulnerabilities are associated with that. So here's your CPE, there's your vulnerabilities, which is strange, there's only one, and then again, where they all are, right? Also part of inventory are systems, and systems are a logical grouping of devices. Think of like a safety systems or a convergence line, grouping systems together. Also part of that is networks. So networks inventoried, what type of networks there are. So in this example, I'll show you what network inventory looks like. So first thing you'll see here is topology is being created, and that's being created right now. It's going to take a second. There we go. You will also see your total utilization of the network, as well as a map. Once again, customers upload these things because they actually want to know where things are. You have your utilization, you have your free IP range and individual addresses, as well as any reserved addresses, and an entire address list. Once again, click through. You want to know more information about the device, you click on it and get more information about the device as well. All right. And here's what that topology looks like for this particular network. As I said, anything in gray are network devices, purple are PLCs, pink are actuators, blue are workstations. All right. What you can also do is join more than one network and do a joint topology. So that's being generated right now as well. Now remember, all of these diagrams are accurate within that discovery window. So if you use your device level rings here, big switch, PLCs. But let's say you wanted to, for some reason, you want to know what this looks like in the Purdue model. But let's change the view. There's your Purdue model. But most importantly, maybe you want to know what that IP networks looks like, what the physical overlay is generated right now as well. So here's your logical networks, and there's your physical connection. And all these can be exported. The inventory is locations. Very important for companies with large manufacturing with multiple sites. So you can take and inventory an entire site as well and show site. So in this example, back to my Flat Rock facility, let's look at that entire site in one view. It takes a second to load because of the internet. So first thing you'll see here is a map. Then you will see a site map with systems notating where they are in the buildings. And these are live. So you could hold over this, hover over and get an account of the devices and click through and find the system as well. There's also topology being drawn, but also at this site, you can see all the networks, what type of networks there are as well. So you can see it's a Profibus, there is Circus, ControlNet, DH+, etc., EtherCAT networks. Then all the systems that are involved with this location, as well as then all of the individual devices. Okay, back to that topology, which I'm sure I have to force it again. So this is a location topology. So it's going to show your segmentation and very granular view of that location, even down to the server room where devices are. If our internet allows it. Just give it a second. So while we're waiting, any questions so far?
What's
Serial? A lot of times you'll need it. But you are able to import Excel files. So if you have those devices in Excel, you can import those and then it will show here like anything else.
Well, so what we run into is, and this is my first time,
Mhm.
you know, but very, 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 very few people do rail.
Absolutely.
Right. So like what you have here, I think is great.
Right.
I don't know. Like if you have 15,000 local workers,
Mhm.
they're always going, always on the road,
Mhm.
getting dead spots, where people are always on it. We don't have the chance to get on a logo, get an Excel file, put it in, right?
So I would say to your questions, I know where you're going with this. We specialize in oil and gas and manufacturing. So the protocols necessary for your environment may not be supported here. But that being said, if the business case exists for that, that's something we could explore. So some of the things you see that don't necessarily fit your business model, it's because we're very much tailored for large manufacturing, oil and gas. And I've had many conversations recently with rail, and that was the same thing. Like, well, it's great, but can you add this because we need this functionality? That's something you can talk about, and that would be a business case usage. But it would be a possibility to go down that road and look at it.
Now, most of our stuff is IP based, right? But
Yeah, we're not going to be able to see the technology. So I think we'll just call it a day here, and we'll talk about your question. Any other questions? All right. Well, thank you.
This morning we are checking out a story that broke the news a couple of weeks ago by the Dutch newspaper De Volkskrant, and they have revealed the latest secret on Stuxnet. Certainly, that is something that we need to discuss. According to the Volkskrant, the original infiltration into the Natanz fuel enrichment facility was actually achieved via water pumps, a shipment of water pumps. And this is something that we need to check out. It's very frightening. It's very exciting, because if that were true, then just imagine what that means. If you can hide a deadly computer virus on a water pump, then anything is possible. So far we only heard about actuators, which is what a pump is in the context of this is where the physical consequence happened, but we didn't hear about those actuators as potential infiltration routes. And just imagine if that is a possibility, just think about, for example, the water pump that is part of your water sprinkler or your lawn sprinkler. All the shit that could be on there. So therefore we need to dive in and see what actually happened and how this is possible. So let's go back to the original article in the Volkskrant. It's in Dutch, but I have translated the essential part of it. And it reads, but what the CIA director, they're referring to General Michael Hayden, who, by the way, also presented at S4 a couple of years ago. What the CIA director did not tell the Dutch services, meaning the Dutch intelligence services, was that the water pumps contained the infamous computer virus, the water pump that a Dutch engineer shipped to Natanz. So this is what they are reporting. And AIVD officers involved in the operation also did not know what was hidden in the equipment that went to Natanz. An intelligence source, quote, "The Americans have used us very hard." Well, basically that's what the Americans do, right? This is what their intelligence services, the CIA, does to other people all the time. Yes, congratulations. This is how it is. Now, unfortunately, this is all the detail that we're getting from the Volkskrant. So it is left to us, OT security experts, to figure out the technicalities behind this frightening attack vector. And this is what we're going to do. So here we have the Dutch contractor who was shipping these water pumps to Natanz end of 28, not 2018, that's a typo here, end of 28. And this shipment contains the infamous computer virus on the water pumps. Then what we know from the forensics about Stuxnet is how the compromise actually works. This is what you see down below. So we have centrifuges that are spinning out of whack. Then we have the Siemens PLCs that control these centrifuges, and we positively know that the virus or the malicious code got onto the PLCs via an engineering station. That is what we know from the forensics, okay? Now we need to piece together how the virus from the pump could jump onto that engineering station. How is that possible? Any ideas? Remote?
Wait, I don't know.
Difficult, right? It's tough when you think about this. Any other ideas? A water pump.
Reinstall it.
When installing the water pump. Water pump is an analog device. It's just physics, okay? You control a water pump via analog means, via electrical electricity, not with bits and bytes. You control a water pump with energy. You can switch the pump on by sending energy to the pump, and you can switch it off by cutting the energy, the electrical current. If it would be a variable flow water pump, so where you can just change the speed, this would also be controlled in an analog fashion. This is done via what we call a variable frequency drive. The variable frequency drive changes the alternating current, the frequency of the alternating current. And this is how you control the flow rate of a variable flow pump. So everything is analog, okay? So how could that virus jump onto that engineering station? You physically put it there, you just throw the water pump on the engineering station. Okay, so let's try to untangle this. A water pump has no memory. It doesn't have a processor because it doesn't execute digital logic. Therefore, it also has no digital connection. So what do we make out of that? In order to further complicate matters, allegedly, this infiltration happened at the end of 2008. At the end of 2008, Natanz was already infected with the first version of Stuxnet. Just in case you didn't know, there are two very different versions of Stuxnet. If you don't know that fact, you don't know anything about Stuxnet. If you want to do a refresher on Stuxnet, either read my paper To Kill a Centrifuge or watch the video, The Stuxnet Story. Both are online, okay? So, in 2009, we saw the infection of the centrifuge drive system. The centrifuge drive system is what controls the speed of the centrifuges, okay? Now, the thing is, in that centrifuge drive system, there is no water circuit. There are no water pumps. The centrifuge drive system is controlled by Siemens S7 controllers. No water pumps. There would be water pumps in the cascade protection system that was attacked in the first version of Stuxnet. But that infiltration already happened in 2007. What do we make out of that? So, the takeaway is, this just cannot have happened the way it was reported. It is physically and logically impossible. And what I would like you to understand is, well, this happens every now and then when media folks just rely on interviews that they usually do with unnamed sources. Like in this case, the source for this article is not identified. They refer to it, and then General Hayden said this and that. Allegedly, reported by somebody who allegedly was present in the meeting, but who is not identified. And when that is the basis of your reporting, you will end up with serious mistakes, and you will end up with bullshit. So unfortunately, this reporter did not bother to check the validity of these claims with technical experts, because engineers would have been able to tell them right away, oh, this is just not possible. It does not add up. It cannot have happened this way. It's impossible, right? And I don't want to put all the blame on the Volksgrund, because, as I said, this happens every now and then. We have seen it, for example, at another place when you think about the original reporting on Stuxnet, which was mostly done by New York Times reporter David Sanger. So the bulk of the story about Stuxnet was published in his book Confront and Conceal, which is about the Obama administration. And if you remember, well, Stuxnet was originally developed by the Bush administration, George W., but then it was continued by Obama, okay? And in his book Confront and Conceal, Sanger reported on Stuxnet at length. It was the first big piece where it was made public. And Sanger mostly relied also on his sources in the Department of Defense. He did a lot of interviews. He also did interview this person. So in this book, I'm the only person who provided some technical intelligence, some technical detail on how this all worked, okay? Now, after the publication, when I read this chapter about Stuxnet, I was, man, you know, this piece totally doesn't make sense. I'm reading you a quote from his book. The trick was to get the beacon, and that in Sanger's parlance, that's part of Stuxnet, into those programmable logic controllers. The best way was on small thumb drives, which could be plugged directly into ports on the controllers. And he's referring to Siemens S7 and Siemens S7 350. Now, guess what? These controllers don't have USB ports. That's not possible. And when I read this, I was, man, David, why didn't you ask me? So I next time I was in Washington, D.C., where David lives, I said, well, let's meet. And I want to something straight here, right? And we actually met near his place. And I told him, David, I mean, why didn't you ask me? I could have told you. This is not possible. And then a very interesting thing happened. David Sanger said, oh, no, Ralph, I don't think you're right, because my sources told me. And David, these devices don't have USB ports. Yeah, but you know, somebody told me the Iranians had developed their own controllers. Obvious bullshit. This is complete BS. But it tells you a little bit how the media works. It tells you how they go to great lengths in order to not kill a story. And the other thing that you should keep in mind here, reporters usually already have a specific twist of the story in mind before they start to actually gather the evidence. And we have seen that, especially with Stuxnet, where I was involved to a great deal, and in various places, right? So they have their preconceived idea on how it would have happened, what they want to tell, and then they try their best to make the evidence that they have, or let's just say the sound bites, etc., support this specific narrative. So my point is, well, yeah, we have seen that in the Volkskrant recently, but we also see that in other publications, even in those which do have a high level of credibility. So David Sanger is one of the most distinguished foreign policy reporters in Washington, D.C., but even he did not bother to go all the way and check all his facts, which would have been simple in this case. It would have been very simple, but it would have destroyed this piece of the story. That is what I wanted to tell you. Any questions about this?
Okay, thank you guys.
No, Siemens did never really have any comment on Stuxnet that was of any value. Siemens used to shy away all the time. They did not want to talk about Stuxnet for obvious reasons.
ServiceNow SGC integration, the Service Graph Connector integration, as well as the vulnerability response integration, which is offered as an add-on to the Service Graph Connector for OTbase. So to start with, we're just looking at the ServiceNow store, which is where you will go to find the OTbase applications. Anybody familiar with ServiceNow is going to be pretty familiar with this process. Pretty straightforward. Select your application, go through the install process. It will automatically prompt you to install any necessary dependencies that we have added into the application scope. Once you've gotten those applications installed and all of the necessary dependencies, then you will wind up in your instance with a couple of things here, and we'll actually go back to we'll go over here to the instance one more time to show how this looks on the nav bar. So you've got it all installed. There we go. Once installed, it will show up on your navigation bar over here. So we have OTbase. We have the import schedules, setup, connection and credential alias, data source, import set, and support. Same with the VR integration. So the first thing you're going to do is come over here and do your guided setup, which really just involves one primary task, which is to configure the connection and the credentials, all of which is a pretty straightforward process. Again, if you've done anything in ServiceNow, you're probably familiar with this process. But basically, you'll create your connection, which we can see over here. Go ahead and load that up. That would look something like this. And then you would specify your mid server. It is required that you have a mid server to run the Service Graph Connector. That would look something like this. Both of mine are down right now, but that's okay because I have them running on another instance. We don't need it for this demo, but mid server is required. Once that is configured and specified, you will be able to come over to your guided setup and test that connection very simply by running the configure on the test API. Now, also, it's important to know that the credentials we looked at through here, you do need to specify your own credentials. You need to create a record in ServiceNow, and that's what you'll use to log into your OT-based REST API through the Service Graph Connector. So you've got everything in, you've configured it, you've tested the API connection, everything's working. The next thing you would want to do is, although we didn't put it here, what we would probably want to do is set our import schedule, which actually can be done through the guided setup as well. But essentially, this is where you tell ServiceNow how you want to run the import to get this data in, how frequently, and at what time, and all of that. So, you know, we might run it daily. We don't have a lot of changing data in the demo database, which is on my server. So we don't have it running, but typically our customers will set that up on like a weekly schedule, and they'll run that at midnight or something like that. So you're pulling your data in, that's all fine. Now, what do you do with the data? Well, that populates into a few key tables within ServiceNow, one of which is the OT CMDB OT entity list. That is your CMDB table where you'll look at all of the OT devices, their display name, the device type, the class, the manufacturer, etc. Also, another table that will be populated, standard ServiceNow stuff, would be your configuration item table, or the CI table, as it's referred to in the ServiceNow world. And this is all really a lot of the same information that's just populated in different ways, in different tables, so that it can be used in the various ServiceNow applications and plugins to build dashboards and analytics and all that sort of stuff. So within the VR side of that, it's a similar guided setup process, very simple. Configure your credentials. Then you populate a couple of other tables, such as discovered items, your vulnerable items. And the vulnerable items table is really a table that sort of marries what you've already pulled in the SGC with the data you've pulled in from the vulnerability endpoint on the REST API. And that gives you your vulnerable items table. So how does all that look once you've pulled the data in from your from your REST API on your OTbase instance, and you now have it in ServiceNow in the CMDB and the CI table everywhere you need it to be. That gives you access to a lot of out-of-the-box workspaces and dashboards that ServiceNow has built available to anyone using this. Of course, there are also a number of other ways that you can display this data. This is one example where we're looking at Microsoft licenses on all of these devices. And this is just an out-of-the-box dashboard, but you can completely build and customize your own dashboards. Maybe you want to see all of your OT assets in one dashboard, and you want to have them broken down by type or location or any of those parameters that are available in the data set. You can do that all here. But that's also available in your industrial workspace, which is an out-of-the-box dashboard through ServiceNow, which is going to show you your OT devices by Purdue level, by type, RTU, PLC, operational technology, by manufacturer, by criticality. All of that will be displayed here. And it will also have your breakdown by category. So you can click into each one of these and see the actual back-end table, which is really just a slice of the table. And then you can manipulate those from there. So in addition to that, we have some new dashboards in the Washington version of ServiceNow. This dashboard we're seeing here, the Operational Technology Vulnerability Response, is an out-of-the-box dashboard built by ServiceNow, available in the latest version. I believe there's still some work being done on these widgets, but for the most part, this is just another way to view your vulnerable items and any remediation efforts you might have that are ongoing, and sort of a high-level dashboard for C-level to look at this and see what's going on in the field, or maybe a leader in that space who's managing the people who are actually doing the remediation efforts. Another dashboard we have is the Vulnerability Manager workspace. So once you have the Service Graph connector, the data pulled in, and you install the vulnerability add-on, you have access to the vulnerability dashboard, the workspace, which is going to be basically a breakdown of all of your vulnerabilities across all of these devices, broken down in a number of different ways. What we're seeing here is the out-of-the-box dashboard. But you can also go to watch topics. Now, we've configured these watch topics here. Out of the box, they're a little bit different, and we felt like we really needed to modify these to suit our specific needs, and you probably will too. But essentially what the Vulnerability Manager workspace does is allow you to view all of your active vulnerable items, the CIs that are impacted, configuration items that are impacted by those vulnerabilities, the distinct vulnerabilities, and then the actual vulnerable items. So we viewed that vulnerable items table. That's where this data is coming from. And so once we're in here, it's a great place to create a remediation effort, for example. Well, I probably don't want to create a remediation effort to remediate 60,000 vulnerable items, but I might go in here and select a subset of that. Let's say I want to see all vulnerable items on this one configuration item. So I'll come over here and I'll say show matching. That's now we have 4,800. That's a little more reasonable, right? But I still have a little bit, quite too many for a single remediation effort. So let's say I want to view just all of my computers. That didn't change us much. That's all right. We'll go with, let's go with something specifically of a risk score of 60. So we come over here, we show matching. All right, now we have 1,600, great. So now maybe I want to create a remediation effort to remediate all assets with vulnerability, with vulnerable items on them of 60 or higher, right? We can do that. We could also be more specific and say, well, I want to remediate everything within this group that has a piece of software installed on it that's making it out of compliance, maybe something that shouldn't be there. All of that can be done through the Vulnerability Manager workspace. You can create and track those remediation efforts over time, assign tasks within each broader remediation effort, assign those out to your team members, and track the progress of those tasks over time. And although we won't get into it here, because we don't want to get that far in the weeds, it does allow you to, as you're going through the process of moving through statuses within those remediation tasks, you can create change requests for your team to do different things. Like if you need to put in a ticket for your internal team to go update a piece of firmware on a operational technology device, within the workflow, you're able to do that within the ServiceNow vulnerability management workflow. So there's a lot of subtasks that can be created and assigned out to the various team members to remediate and then track that over time. Any questions? No? Well, I think we're going to end it there for today then. If you have any questions about the Service Graph connector or the vulnerability response add-on for OTbase, both available currently within the ServiceNow store, please contact one of our reps over here at OTbase and talk more about it. And, we'd love to share what we're doing. And we have the ServiceNow guys here in-house this week as well. Be happy to pull everybody in and we'll really show you what this thing can do. Thank you.
People in the OT security space are obsessed with threats. Why do I say that? Because when you look at all the publications on the discussions on LinkedIn and other social media platforms, it's mostly about the latest threat actor or the latest malware strain, etc. And that has the tendency to lure practitioners and, let's just say, the blue team, the defense team, into an area where you are fighting a battle that you can never win. You will never be able to always counter the latest threat, the threat du jour, as the French would say, right? And just think about that. So hear me out. I think it's counterintuitive, but hear me out. Just analyze or just check how long it takes the average asset owner to make any planned configuration change when it comes to implementing OT security measures. Well, I can tell you, based on my experience in 20 years of OT security consulting, it may take a couple of years. Let's just say best case, a couple of weeks. Okay, now tell me how that should work, that there is this new threat coming out and then all of a sudden everybody goes in panic mode and focuses only on this new threat or this new malware strain, this new exploit. How should that actually work? It won't work because you will always be too late. You can never keep up if you are in reactive mode, right? So that tells us we must do something proactively. We must already be prepared. In other words, what I suggest to do is to focus on a long-term strategy where you strive for incremental improvements rather than always be in reactive mode and react to the latest publication on that new threat vector, that new botnet or whatever it might be. And guess what? That long-term strategy in most cases isn't rocket science. So when you think about all the vulnerabilities that define your attack surface, what do you expect to find? You will not find totally unexpected revelations. Oh, damn, we have this very specific vulnerability that only affects us. No, it's not like that. You will see basic, even banal vulnerabilities that pretty much every other asset owner is plagued with as well. What do I mean by that? Just think about typical examples. Think about outdated operating system versions. Think about something like Windows XP systems, systems still running Windows 7. That is a reality on the plant floor. You don't know how many of you have, and then you just check your OTS. That's a snap. You will get that list right away. You can even enter a policy, Windows 7 is not allowed in our facility, and all those devices will be singled out, and the users will get a notification about that. So that is very simple to do in principle. So certainly to update those systems, that's a different story. But it's much more efficient to focus on those foundational problems that define your attack surface, rather than on those than to get into that event-driven mode of thinking and of acting. Okay, let me give you another example. Software products such as Adobe Flash Player or TeamViewer, they have no place in an OT environment. If you just single them out and if you remove them from the specific systems, then your security posture will dramatically rise. And how can I say this? Well, because we have the numbers. In OTbase, you get the numbers. You can see how much each of those software products contribute to your attack surface. How many unpatched or vulnerable systems you have with these particular software products, how much they contribute to your overall CVSS score, right? So that is, I don't have to guess, I can tell you in some kind of metric fashion, right? So you get numbers for this. And that is the different mindset that I suggest you to adopt, or at least to consider, that in order to really make progress in OT security, stay away from the latest threats, from the latest malware strains, from the latest report that an OT security vendor has published. Just focus on your attack surface and what you would need to do to achieve meaningful reductions of that attack surface. What do I mean by meaningful? Well, like something like, but what will be the net result be when you take a simple metric such as CVSS base score, for example? So you just need to add all those CVSS base scores. That gives you a good metric. Right? And then if you have eliminated all those CVEs, and then you can see that number shrink. That's a good metric. It also will show you, it will give you an idea, well, that's a lot of stuff that's affected by this one software product, right? That's a lot of attack surface that is created by that. So that would be a more sustainable approach, and also, as anybody can understand, that is unrelated to a specific threat, because all of these latest threats, they all exploit something that in the OT space has existed for many years. So the most important malware or ransomware or whatever it might be is not associated to that latest 0 day. No, it's related. It's exploiting vulnerabilities that are well known for years. How do you find out about those vulnerabilities? Well, you just go to OTbase and you will see it. You can measure it, and that is where you get really solid data that allows you to find the right direction to make meaningful progress when it comes to reducing your attack surface. In this next session, we are talking about cyber-physical modeling as it is implemented in the OTbase OT asset management system. Let me start with an introduction of why this is a thing, why this is super important. It's actually very simple. If you look at the average OT asset inventory, basically you're looking at a bunch of individual devices, like in this chart here. So have some statistics, charts, etc. These are all individual devices. Each row represents one device. In other words, this is kind of like an atomic view on your asset inventory. Well, that's very nice because it already contains a shit ton of data on those particular devices. However, for certain use cases, such as vulnerability management, it isn't enough. You must have metadata. And what do I mean with those metadata? Well, to give you an idea, if you look at the first two columns in this table, you see what we're talking about. First, the first column is about geolocation. It tells you where the device is located in the plant. This information, you're pretty much lost because the asset management in OTbase usually for our customers, it's a full inventory. It covers all the assets over all of their sites. And certainly, if you don't know which site you're talking about, that doesn't make a lot of sense. It gets even better when you're able to pinpoint that device to a specific building or room or cabinet. But in this talk, we are focusing on that second column, OT system. And that is related to the function that this particular device belongs to in other words, for example, I would say in ISA 95 parlance, that would be something like the work cell as an example. That is even more important than the geolocation because it really relates to function and therefore to criticality. It is also super important for anybody who wants to implement a network segregation strategy, because here is the kicker. For your network segregation strategy, the Purdue model doesn't go a long way, because the idea behind Purdue is a horizontal model, right? You're talking about a hierarchy that is structured as horizontal layers. Now, what is the problem with that? Your horizontal layers might go across various work cells or zones, right? So that is not really a good segmentation strategy if you would rely on that model. Because let's just assume here for a second, you would place all your PLCs in one specific layer that you protect with firewalls, etc. But if that one layer is compromised, that specific zone, if you will, then your whole production is going to go down. And if you look at work cells or functional entities, on the other hand, what we call OT systems in OTbase, that's a totally different story, because you can single out those systems that work in concert. And that means that if any component within that system goes down, well, that particular system will face an outage, but other isolated systems will not. Very simple example. When you have a production line with, or when you have, let's just say, two production lines producing the same type of product, then if one of those lines is compromised and faces an outage, the other can still produce product. And that would not be the case if you use a strict horizontal approach. So this is what the OT system capability is all about in OTbase. And it gets much better than this just one column in the inventory, because we are now looking at the devices inventory. But in OTbase, we also have a systems inventory where you only see those systems, those high-level systems. And the best part is those systems can be hierarchically structured like so. So I'm singling out here this one system that is a hypothetical power plant, an electric power plant with two different units. And for these units, a turbine island with an electric generator, with transformers, a turbine, and so on. And what I can now do is in OTbase, as usual, I can drill down in order to get the system profile. as we call it. And in that system profile, I'm going to see those various subcomponents or subsystems. And as you see, I can also see relations between those subsystems. That is like the big new functionality in OTbase 8.1, that you not only can model hierarchical system structures, but you can also model the relationships between them. And here is where we go into Cyberphysical, because you can identify and document the various physical relationships. So if you take a close look at this diagram here, you will see down here we have the turbine part where, the heat generation part, where steam is pushed into the turbine, and from the turbine it goes back via a condenser and re-enters the feed water system. So this is one circuit down here, and the relationship is water and steam. That's purely physical. And up here we have the electricity going out. So from the turbine, the turbine produces torque that drives this generator. The generator sends its 11 kilovolts to the transformer, and the transformer sends 400 kilovolts to the switchyard. And the switchyard obviously is also fed by our other turbine, okay? And this is all physical. And then you have the digital dependency, if you will. So this is controlled, these two units are controlled by a SCADA system, or in this case, we have used a Siemens SPPA T3000 system that exercises the process control. And we can see exactly the entry points here. We can see the dependencies. We also see there is an additional generator protection system as part of the electric generator that does its own thing besides the SPPA T3000. As you can see, everything can be remodeled just by, so this is fully interactive. You can just zoom in, zoom out. You can choose different layouts depending on the use case that you are focusing on. But at the end of the day, it's all about to identify cyber-physical dependencies. Again, why is that so super important? Because that's your best shot of identifying zones that you can use for network segregation. And the other thing, well, what it's important for is for identifying criticality. Because criticality cannot be determined like in IT by just looking at the nature of a specific Windows box, or by just looking at a PC. If you would say, well, this Rockwell control module here, or this Rockwell rack, this must be pretty critical because it's a PLC. That's nonsense, right? It all depends on the function. And in real life, it goes even beyond that. You couldn't even say, well, there are, let's just say, 50 or there are 10 I/O modules in there. It must be important. No, that's not a thing. You have to analyze the functions that are executed or controlled by this particular rack. This cannot be done by an IT person. This can only be done by talking to the SMEs, to the engineers, to the operators, for example, who actually know what the purpose of these particular components are. So, for example, I must know what is associated with the turbine. This is kind of like a high-level model here that we did, but in reality, you would go much further down. So you would elaborate on that, on all the subcomponents of the turbine. You would most likely factor in the turbine lubrication subsystem, which we have just suggested here by exposing this turbine protection system. So there are a couple of components associated with that big turbine, and by identifying those, you have a fantastic opportunity to identify critical components and then protect those critical components properly. Maybe the most simple example that you can think about is when you think of a factory environment in manufacturing. discrete manufacturing. Think about those mundane support systems, such as chilled air, such as air pressure. Or you probably wouldn't have them high on your agenda by just looking at how many PLCs are involved, for example, how complex the control logic is. No, these systems, those support systems, are super simple. But if they fail, in many cases, the whole site is down, right? How do you determine that? Just by doing such a cyber-physical dependency analysis. This allows you to actually identify critical system components. And this is what you can now do in OTbase interactively. You can just generate those diagrams. All of those dependencies here are fully customizable. So the colors that you use, the thickness of the lines, just for example, what you see here, some lines are dashed, others are not. This is up to your preference, right? So you can really end up with something that makes sense to your users using probably some existing corporate standards. So let's quickly look at another example in that space. Let's look at a manufacturing sample. In this other example here, we have modeled a production line for food. So think about yogurt as an example. Let's magnify this a little bit. Difficult with the trackpad. This is a little bit more complex. Up here, we have a raw material handling unit. And from there, you see the raw material goes into a mixer with preprocessor, reactor, etc. Then you see the various dependencies. Here we got a DCS that exercises process control for the raw material handling and also for that mixer. And that mixer is redundant. And from that mixer, when you go further down, we also have a filler line where the product is bottled and put and packed into trays and finally put on pallets, right? Again, what I wanted to show you here is these diagrams can get pretty complex, but it's easy for me to change the layout so that enables me to focus on the use case at hand, okay? So I've now reduced this filler line, which also has some redundancy, and this allows me to really focus on specific questions. If I want to single out specific subcomponents, I immediately see their dependencies with other components. You know, just by hovering over any of these boxes or any of these lines, I get additional metadata, I get contextual information, and I can also, if I want to, just get rid of some of the relationships that are not important for my use case. So for example, packaging, I'm not interested in that. And also let's just say, get rid of the material. I only want to focus on those three. And this will automatically redraw the diagram and make it simpler to understand for the use case at hand, depending on what I want to analyze. So just to give you this idea, this is now a thing in OTbase inventory 8.1. Finally, let's look at the last sample, which is our Flatrock site, where we have our body in white building. And the important thing is that for all these subsystems, you get the full stack of all the endpoints that belong to those subsystems. For example, here we have singled out, well, these power flexes, they belong to the trunk cell, as I have mentioned in the introduction to my talk. Well, I would also see the physical location of those systems, but here what's more important is the functional context of these individual devices. And I can also now do a network topology for this system, where the devices and their network topology are also reflecting the association with those cells, right? So when I look at this topology diagram, which is created automatically, I can now see exactly the network topology and devices which are part of that trunk cell, as opposed to those that are part of the frame, of the hood, etc. So in other words, once that you have defined your cyber-physical model, once that you have told OTbase, okay, these devices, these OT devices belong to that trunk cell as an example, everything else is put together automatically. There is no more manual labor involved, and then you can get real with your analytics, which will give you a lot of insight about your system criticalities, and it will also allow you to get a lot of insight about segmentation opportunities. It's very important, very helpful. Check it out on our website or approach us at our sponsor room at S4 while we are here. Thank you very much. In OT vulnerability management, your criticality is not the most important data item that you want to focus on. And why is that? It seems to be counterproductive. Well, I would say that's IT style thinking. What do you really think the criticality relates to? It is an expression about the badness of the vulnerability, about all the potential bad things that could happen once that the vulnerability gets exploited. Unfortunately, that consequence that you're interested in OT is not reflected in that assessment by MITRE or in that CVSS base core. It's not in there because the consequence or cost of consequence is in the physical process. And that is something that MITRE or NIST doesn't know about. So that is up to your analysis. And that leads you to the realization, okay, actually the criticality, the severity rating of that CVE is much less important than in IT, because what I should focus on is the criticality of the affected system that could be impacted by that particular vulnerability if it were exploited, okay? So that is what I want you to do. You check out the criticality of your OT infrastructure, and you could, for example, start on a cell level or on a machine line level, right? And in OTbase, this is very simple because you can assign criticalities to OT systems, so to conglomerates of individual OT devices. And based on that gives you a better angle to furnish your vulnerability management strategy. Since now you will be able to see, okay, I'm affected by CVE X, Y, and Z for those areas of my OT infrastructure where it really matters, where I really should arrive at a mitigation quickly, whereas when it comes to other devices that might be affected by the same CVE or even by a more critical CVE, well, you just don't care. Why don't you not care? Very simple, because you have limited resources. That is like the overarching big theme in OT security. You will never have enough resources. You will never have enough budget. Therefore, prioritization is so super important. And the way to make it happen is you need to bring in that context that gives you a wealth of additional pointers that allow you to furnish a vulnerability management strategy that really achieves results. And again, you will not achieve those results by focusing on those CVEs where MITRE tells you, oh, no, severity is critical. No, that is IT style thinking. That doesn't give you a lot of mileage in OT. So therefore, you start with a functional analysis of your devices, and you associate that data point with all the other pointers, such as CVSS base core as one other data point, or such as the network exposure of that device or of that network. That all comes together. Another data point would be, is there a known exploit for this particular vulnerability? And all those things, believe it or not, are actually already implemented in the OTbase OT asset management system, right? So everything comes together there. And therefore, at the end of the day, when you do your risk assessment, when you look at all those analytics that you get from OTbase, your data is much more valid than if you would only focus on the severity rating as assigned by MyTree.
Welcome back. Today I'm going to go through what a comprehensive asset inventory system looks like. And I guess maybe before that, I'll take a step back and say how we got here. So having a comprehensive asset inventory system requires automatic discovery. And that automatic discovery is, in our case, that is an active only solution, meaning we actively query the devices in the legitimate industrial protocols to get the information back from them. So once all the information comes back, I'll show you what it looks like in OTbase. All right, so now what we're looking at is our inventory page. And first thing you'll notice, there's a color coding that goes along with the device types. The first device type that I have here are gray, and those are your network devices. Then you have your blue here, which are your workstations, your pink, your actuators, and purple are PLCs, right? You also notice there's a chart up top, and every chart that you see in OTbase is dynamically generated based on that discovery that we just talked about, right? So you see your top device vendors are, there's Marshall Rockwell here, there's some actuators and some Ethernet cards, right? So let's look at a PLC. Find one for us right here. Right, so this is the device profile of PLC. And you'll notice at the top here, there is a site map. And a lot of the customers will upload site maps and use that discovery that we just talked about that has location data to populate those maps. So you know exactly where these devices are. Right, so from this portion on, everything down is automatically discovered. We automatically discover the vendor, the model, the version when known, the type, the life cycle phase, and this is important when we start talking about obsolescence management, as well as the serial number, CPE for vulnerability matching, your catalog description, and a link back to the vendor page. So on this particular PLC, you'll see all of these cards here, and we also show the slot that the card is occupying, as well as the vendor, model, firmware, serial number, and a description of each one of those cards. So not only do you have the PLC and all of its metadata, you have the cards on the backplane as well. And if you look at these cards quickly, you'll notice that each one is red, and that red means that that card has outdated firmware, right? So keep scrolling down. You have your network connectivity, and there's another diagram. And like I mentioned before, all diagrams are dynamically drawn. So if this particular PLC was connected to a different switch, when discovery ran through, it would create an updated map to show that connectivity. Right. So we go down to firmware, you can see, well, the actual base firmware for this particular PLC is outdated as well. So jump into security really quickly. You'll notice that it shows 0 for known vulnerabilities because we're looking at known exploited vulnerabilities first. If you uncheck that, you'll see this device actually does have a few vulnerabilities. So let's look at them. We'll jump into the first one here, and this is a critical one. So you'll notice we're in the vulnerability profile, and you'll see your criticality, your base score, your CVS vector, when it was published, and it does not have a known exploit. You will also see the description of the vulnerability. In this case, it's a buffer overflow vulnerability, your links, and most importantly, where these devices are. So if you were to think of a notice, a service notice from one of the vendors that said you needed to update this firmware because of this vulnerability or whatever functionality. The issue you have when you don't have a comprehensive inventory is you end up chasing, trying to figure out where this device is, if it's part of a critical system, and how many you have. And that's not, you can't really do that without a comprehensive inventory. Right. So we looked at a PLC. Let's look at a switch. I'll grab a Cisco switch. So again, you notice that that map has been uploaded, but you'll also notice here that this switch has been given criticality, and it's critical to the business continuity line. So that's a very important distinction in OTbase. You can take a device, a system, and give them criticality, which gives them a higher priority in your vulnerability management. All right, so we discover your vendor model version, and this device in the lifecycle is phased out. So there's part of your obsolescence management. Serial number, CPE for vulnerability matching again, and your catalog description and link. So on this particular device, you'll see the entire port list, which slots are being occupied, negotiated speed, and which device is connected to it. So anytime you see something in OTbase that has an underline, that means you can get more information about it. So if we click on this device here, it shows us that this device is a virtual machine with all the information it showed before. And you'll notice that this device has criticality for the engineering systems. Okay. Last device type we'll look at a workstation. Grab a virtual machine. Virtual machines are also part of inventory. Once again, you'll notice that that map is there. This is a Windows 7 machine, your service pack, and it is end of support. All of the software that is on the machine is also inventoried, including its version, because that plays a huge part of your vulnerability management. So if we scroll down, you can see any patching that's been done and when it was done. Jump down to security real quick. If you look at security, you can see that this device does have some security software pre-installed. And you can see a histogram that shows the last time this device was patched. You can see the last time this device was patched was in 2018 and 24 patches were installed. All right, so now we're back in vulnerabilities. And you'll notice that it has 171 known exploitable vulnerabilities because that's what we prioritize first. But if you uncheck the box, you'll see the real picture of how big the problem is. So this one device is sitting on vulnerabilities. So we'll just jump into critical first. Anything that's highlighted with orange has a known exploit. Let's look at a Windows vulnerability. All right, so you have your criticality, your base score, which is very high on this one, 9.9. Your CVS vector, when it was published, your description, links, and then your recommended remediation. So here are those patches necessary to remediate the ones that you can remediate of the 4,900 vulnerabilities on this device. And most importantly, again, where these devices are. It's one thing to have vulnerabilities that come in every day. There's another thing to be able to find which ones are important to patch, the ones that you can. So this shows you the location. Also, if you have actually done any work to remediate this particular vulnerability, it'll show that that's been fixed as well. All right. So we've looked at a couple different device types. Now let's look at software, because software is part of that inventory as well. All right, so all the software from all the devices are inventoried and the version of that software. So for instance, if you wanted to know how many instances of this VMware tools do I have installed, it'll show you the CPE as well as all the known vulnerabilities for it. And you have 83 of these installed, and this is where they all are. So if you expand it, you can see this is where these vulnerabilities reside. I mean, this particular piece of software resides. Also, systems are inventoried. And you can think of a system as like a logical grouping of devices that form a function, like a safety system. All right. We jump into networks. Networks are also inventoried. The types of networks as well. So I'll give you a quick example of what that looks like. Let's pull a network. Let's look at a network. Right, so this is our network address space for this particular network. You can see the network utilization. You can also see your IP free addresses and free address ranges, as well as a complete address list. And like I said, anything that's underlying, get more information. So if you know what particular device is this, here's more information about that particular device. In this case, just an actuator. All right. Also, you'll notice that there's a topology that is created. So this topology, like I said before, is dynamic in nature and based on the discovery information. So things move within that discovery window. Next time it runs discovery, programs change as well. All right. Also part of that inventory is locations. So we'll go back to our Flat Rock facility. So we have it broken down by continents, countries. Let's go back to your United States and our Flat Rock facility. This profile view gives you a view of all of those assets that are at that location. Right. So first thing you'll see here is a map. Then there's also a site map that is tagged with systems. And these are live, so you can actually see, how many devices are there. They're clickable. We scroll down a little bit. We'll see that topology is actually being generated right now. You'll see all of the networks that are part of this facility and the type of networks, Profibus network here. There is a bunch of IP. There's some circuits, ControlNet, DH+, etc., EtherCAT, and all of your systems at this particular location on all of those endpoints. So if we go back up to that topology map, you can see what the location topology looks like. Scroll up a little bit. Zoom in a little bit. See? So this is what a location topology looks like. And you can actually see the segmentation inside of the location as well. You can even get a little deeper. You can dig down and see, oh, okay, here we have our devices in this particular cabinet, right? You can get down into a server room and a control room and see devices in there as well. So very granular with that discovery, right? There's no questions. There are questions? If not, we'll be at the booth the rest of the week. If you have any questions, swing by the Moon Room. Thanks for joining. Yeah, your machine generates those.
Okay, so let's talk about one of the biggest misconceptions in OT security, which is related to the Purdue model. The Purdue model is often conceived as something like a security architecture, which in fact it is not. And what I try to explain today is that it can be absolutely counterproductive. So let's dive into that. The Purdue model's heritage is in the idea to just provide some functional guidance on how to conceive a manufacturing process as far as the digital OT and the networking is concerned. However, it does not per se have a direct link to networks and network architecture. Unfortunately, that was misconstrued later on, especially by people who are more on the IT side of things rather than in OT. So you will have trouble finding an engineer who actually uses the term Purdue. That's on Purdue level, for example. You will have a hard time finding such an engineer. Engineers would say, well, oh, those are the sensors, right? And then where the RTUs are, that's that different thing, right? But they wouldn't use the terminology, or that's on Purdue layer 1, for example. So why is that a misconception? Some people think that this layering, as documented in the Purdue model, would tell you or suggest that you would place all those different types of OT devices in different network layers. And that's nonsense, and I explain why. So you would have all the sensors and actuators in one layer. Then on the next layer, you would have the PLCs and RTUs. Then you would have the HMIs, etc. And why is that nonsense? There are a couple of reasons for this. So the first thing is what I think the most important takeaway that you should get from this video is the the important, or like the crown jewels when it comes to your OT when it comes to your cyber physical infrastructure is not the sensors and the actuators, it's the engineering stations. Because once you are on the engineering station, you can compromise the whole physical process. Because then from the engineering station, you can jump onto the PLCs, the RTUs, etc., and then you're cooked. That is what you want to focus on. If you would place additional security layers below that network segment that the engineering station happens to sit on, that wouldn't do any good, because the engineering station will always be able to directly reach all those lower levels. So it doesn't do you any good. The other thing that most people don't understand, even if you would introduce some additional firewalls, etc., once that you have compromised the engineering station, you can actually, so not just by downloading a new project onto the PLCs with malicious code, as we have seen in Stuxnet, but also just as far as the communication paths are concerned, you can totally reach every lower level from the engineering station or from that network where the engineering station sits. How is that possible? It's possible by something that is called Ethernet IP, and especially Ethernet IP route browsing. So what does that mean? The Ethernet IP protocol comes with the capability to route into lower level networks. And that is so the SIP route browsing, which isn't even limited to Ethernet IP, it also extends to field buses such as ControlNet, DeviceNet, Circus, and so on. That already gives you an idea, well, you know, that's bad. Let's just assume I actually had placed additional firewalls between these different layers. Well, if still I can route through the layers by virtue of that layer 7 protocol, then all those firewalls don't give me any security benefit. That is important to consider here. So once that this upper level, that could be layer 2, it could be layer 3, once that this is compromised, your engineering, all your RTUs, your PLCs, your sensors and actuators can be reached as well and can be manipulated. So therefore, the idea that you would place all those additional security measures between the layers is pretty much counterproductive. Why do I say counterproductive? Because it can actually do more harm than good, and let me explain why. The whole idea to use the Purdue model would be, well, we have understood finally that OT is insecure by design, there is no authentication, there is no authorization, so therefore we need to make heavy use of network segregation. That's a good idea. So that is a very important and valid security approach in OT. However, the Purdue model doesn't give you that. The Purdue model would suggest that you do a horizontal segregation of your network architecture, and that's nonsense. I already gave you some reasons, and it goes further. So consider this. When you start your network segregation, what you want to achieve is that in case of a compromise of one specific area, other areas can continue to function so that you can localize the damage. That is what you want to achieve with network segregation. Now, unfortunately, if you do that segregation horizontally, you may end up with an architecture where, let's just say, all your PLCs are compromised, and that means all production lines are stopped or even dysfunctional. You know, they might you may look at the destroyed product, etc. So that is not what you want. You want to localize the damage, and the only way to get there is that you first do an analysis of how your OT equipment is related to process function. And then you identify, okay, these are those individual zones. This is where the zoning comes in, where let's just say we're looking at one specific machine line, right? Okay, if that specific machine line is compromised, all the other machine lines will be able to continue production. This is where you want to go. And again, the only thing to get there is to make that functional analysis of your infrastructure. That cannot be done using Wireshark. That cannot be done using threat intelligence. That can only be done by your engineers telling you, okay, so these PLC sensors and actuators, they belong to this, let's just say work cell, for example, right? To this other functional group. And based on that, you do your network segregation strategy. I would say it gets very clear if you simply look at a network diagram using different layouts. So if you do a layout for, let's just say, one specific building, and you do the layout based on Purdue levels, which is very simple to do in OTbase, right? So you can just do your network topology, and in the layout drop down, you select hierarchy. Bam. And then you see all those network devices and all connections based on that Purdue hierarchy. Okay. And then, so imagine what you would do the segregation at that horizontal layer. And you will see immediately, well, that actually is counterproductive. Now in OTbase, you can also change the layout to a functional display, where now the layout is based on system association. And once that you do that, you can clearly see which OT devices and network gear belongs to specific work cells or machine lines. And based on that, you're going to do your segregation. So bottom line, the idea that the Purdue model was intended or can act as a security strategy or blueprint, that is nonsense. Second, it can even be counterproductive. Don't use it for your network segregation strategy. What you should do is you should first do that functional analysis, and based on that, you implement your network segregation. Management system. But before I do that, I would like to give you some background on how that actually works, how it all comes together, and how it might be different from IT. The way that OT vulnerability management works is that you take the existing set of known vulnerabilities, which are expressed in CVEs, and identify if any of these CVEs affect your installed base. Now, how is that possible? How is that done? Every single CVE contains a description, a specification about the affected products and configurations. And it's really only about products and configurations. So that means you don't need any network anomaly detection to identify which known vulnerabilities affect your installed base. That's a totally different wheelhouse. CVEs are only about products and configurations. And that also means you will not be able to properly identify which vulnerabilities affect your installed base if you don't have an accurate and comprehensive OT asset inventory. In order to get to that inventory, your anomaly detection won't do you a lot of good, because usually what you see in passive identification is that the granularity of the information you're getting from the devices is not sufficient. And that's the simple reason why in some ICS detection products that also expose vulnerabilities, you see a probability associated with that CVE. Now, the reality is, in the CVE definitions that you can look up on NIST and at the National Vulnerability Database at nvd.nist.gov, there are no probabilities. It's either or. So what you see expressed as a probability in ICS detection products when it comes to vulnerabilities is not about the CVE, it's about the inability to properly and accurately identify the device and its configuration. That is very important to understand. CVEs don't have a probability. A CVE affects your installed base or it doesn't. So once that we have an accurate and comprehensive OT asset inventory, we can now run the list of CVEs against that installed base and can see if we find a match when it comes to the exact configuration. Now, what's the problem behind that? It actually is quite a big computational effort. If you just consider that today we are talking about roughly 250,000 CVEs, known vulnerabilities, that may affect your devices. And at the same time, we might also be talking about your 50,000 OT devices that you may have installed, right? And just by looking at those numbers, you will automatically understand why you will never, ever be able to do that manually. Especially if you consider that every single day new CVEs drop down from heaven, you know, or from hell would be probably more appropriate. Right? So this just doesn't work. Also, if you see asset owners or OT security experts trying to address vulnerability management by sifting through those publications from various government entities, from vendors, oh, you know, they're informing me there is a new vulnerability in those, I don't know, Rockwell products. So now let's check out if we are affected by this. This is never going to work. If you just wanted to check out the latest vulnerability, let me give you, let's focus on this idea. So this is because this is what many people do. Let's focus on the latest, in real time, the newest vulnerability that is critical, that might affect our installed base. So first of all, there is a very low probability that you will actually identify all the affected devices unless you already have an automated OT asset inventory. And second, you are totally missing the point, because the big problem is not the new vulnerabilities, it's the huge backlog of vulnerabilities that you are carrying with you. And you will quickly see that once that you use OTbase, because it's going to show you all that backlog, and on top of that also the new vulnerabilities. Let me give you an idea. So let's log on to our demo system here. And let's jump to the events page where I can see what recently happened, okay? So let's just jump to the CVEs that I see exposed here. And this page tells us in the last 7 days, there were 31 new CVEs. I could focus on those, but I told you already a couple of minutes ago, that's probably not a smart idea. I'm just telling you this capability is in the product. So you can actually focus on the latest and greatest, such as this CVE from yesterday. If I want to see any details on this CVE that dropped from heaven or hell just yesterday, I only need to double click on the entry, and I see the description, I see the CVSS base core, I get all the links to NIST and to additional information. And what's most important, I see the affected devices. I see exactly where I have this match. So that let's just single out this one here. I can always drill down in OTbase by just following those links. And this takes me to one of these affected devices within a couple of seconds. And then I would see what's going on here. So this is a virtual machine. And for this virtual machine, I have a security section in my device profile. and I would see all those CVEs with known exploits. And if I uncheck this box, I see the full number of CVEs, and then all of a sudden it jumps from 79 to almost 3,000. You know, guys, sorry. In OT, such a number, so a Windows box with thousands of known vulnerabilities, that's not something out of the world. That happens all the time. So if you see that, it's just normal. But we are going back to this later on when we think about vulnerability mitigation. Certainly, if you are talking about such a high number of vulnerabilities, the idea that you can patch your way out of risk becomes absurd. It will not work. But we will get back to that later. So this is the latest and newest and hottest vulnerabilities. And I can sort and filter that by any means I want. I can also see, you know, let's go back 30 days, then certainly that number gets even higher to 122 vulnerabilities. But as I told you, the big problem is not the latest vulnerabilities, it's your huge backlog. And in order to get an idea about what that means, we move from events to our workspace, especially to our CVE workspace, where by default we end up with this table right here, which gives us a list of all vulnerabilities according to my current filter setting. And you see in this upper right corner, I'm looking at 279 CVEs. But again, this is because this is already filtered. Here in this first column, you see that we have filtered for critical and high severity vulnerabilities, which is what most people do, because if I would also include medium and low, the number will get bigger and bigger and bigger. It's already beyond what I could mitigate with reasonable effort. So therefore, we chose to filter that to critical and high. And we also applied another filter, which is this one here, which is the KEV filter. So we are only looking at vulnerabilities with known exploits. Now let's talk about for a while how we are able to identify that. This information, is there already a known exploit for the vulnerability or not? This does not come from NIST. It's not included in the National Vulnerability Database. In order to be able to expose this information, we also download information from CISA. Finally, one other thing that you see here, you see there is a blue bar, ratio fixed. So there are actually 25% of the affected Windows boxes already patched. How do we know that? Again, it's not in the National Vulnerability Database. It's not in the information from CISA. This is information that we pull from Microsoft, from their security API, where we download the information about the patches. And by combining all of this data, which you will never be able to do manually, we can tell you right away, well, for this particular vulnerability, you have already 25% of the affected systems patched. Okay, but anyhow, getting back to the filters here, if I uncheck this box, the number 279 all of a sudden jumps to almost 10,000 CVEs, just to give you an idea. So that suggests to you that this KEV filter is super, super practical, because this gives you a way to prioritize your mitigation efforts. You will have a hard time mitigating those almost 10,000 CVEs within human time, with human resources, especially if you consider, well, this is already filtered for high and critical, okay? But why is it so practical to focus on those with the KEV? Because KEV relates to probability of getting hacked. If there already is a known exploit, obviously the probability of that particular CVE getting exploited at your site is much higher than if the lazy hackers would have to find and create an exploit in the first place. This is not what they like to do, because they are lazy sons of bitches. Therefore, they prefer to use existing exploits. And this list tells you exactly those vulnerabilities for which exploits already exist. Okay? Again, if you want to get any click, this pops up the what we call the vulnerability profile, and there you see where you have the affected devices, and then you can work from there. This list here is not limited to Windows vulnerabilities. It contains any kind of vulnerabilities. So you will also see vulnerabilities for your Rockwell PLCs, for your Siemens PLCs, and so on. RTUs, even actuators. If you didn't know, there are a bunch of known vulnerabilities for variable frequency drives. That sit on your Ethernet IP networks, and you will certainly also see those. It's just, if you look at the big picture here, the fact that the vast majority of CVEs are associated with Windows PCs. Okay, why is that so? Well, because if you compare a Windows PC to a VFD, to a drive, apparently there is a difference in complexity. First of all, your Windows operating system already is just a total complexity mess with all kinds of bugs that can be exploited, and therefore you're doing this patching as often as you can already. But besides that, you not only have the operating system itself, you can also and will also install a bunch of software that comes with its own share of vulnerabilities. And for that simple reason, you will see many, many more CVEs in this list than for automation equipment. And certainly that shouldn't fool you, but then on the other hand, it's super, super important for the big picture, because if you consider that the vast majority of malware, of real-world attacks and attacks attempt today's is associated with ransomware, is in the ransomware domain, well, then we are talking about PCs. You will not find ransomware for actuators. You will not find ransomware for PLCs. Thank God. I'm not sure if it may come, but technically it would be possible. But again, those lazy ass hackers don't want to do that. They don't want to go there because it's so much simpler to use existing exploits for Windows boxes. And that already tells you, well, no, even though our automation equipment is our primary focus of attention when it comes to vulnerabilities, well, the majority of those are associated. And that will lead us later in my presentation to the question, well, how can I single out those Windows boxes that I really should care about? And that would be associated with network exposure and device criticality. We will go back to that later. Okay, so this is the CVE list. Then we also have a details view. Now this is about individual vulnerabilities. So when we are talking about 279 vulnerabilities, that's one thing. But that was about the CVEs. But certainly a CVE can affect more than one device. And this is what you see here. Now, this list is like a counterpart of what we have seen before, but broken down to individual instances. And therefore, now our number is no longer 279, but it's roughly 2,000, or roughly 25,000, okay? Because all those CVEs can affect multiple devices. And this is the list of individual devices. Now, what you can do is you can slice and dice these lists to arrive at a meaningful data set that you can then act upon. And this is what you see here. Once that I have filtered down that list to something that I really want to tackle with mitigation, I can save those filter settings like you see here. And once that I've done that, I can load those filter settings in this drop down. So for example, what I've done here already is well, let's just only look at Rockwell vulnerabilities, okay? And just like this, now you see that reduced filtered result set where I only see vulnerabilities on those Rockwell PLCs and Rockwell communication adapters. Because one of my users has said, well, this is what I definitely want to focus on. This is what I want to remediate. As soon as I do that, OTbase will also automatically create a report for me, just behind the scenes. And let's quickly jump over to that report. If you go to the reports page, then where do we have our Rockwell vulnerabilities? Let's go down in the list. Oh, we have to first, we have to go to CVEs first. That makes sense. There we go. There we have the Rockwell vulnerabilities. And different from the table that you have seen earlier, this also comes with a couple of charts that give me a high-level view of what we were talking about, which models are affected, for example. Well, guess what? There even is an 8-axis circus interface with a couple of vulnerabilities. Isn't that interesting? Right? You probably wouldn't have expected that. And then we have a timeline that shows you how you're progressing, right? The number of vulnerabilities as it changes over time. In my example, there haven't been any changes because we actually didn't apply mitigation. If you would do that, you would see that graph going down. Okay, so let's go back to the vulnerabilities workspace. We have another table here in this workspace where we now look at devices. And so every entry is represents one device, and obviously one device might be affected by multiple vulnerabilities, multiple CVEs. And based on that, we can do some additional calculations and try to arrive at a score for the actual risk, try to arrive at some metric that would allow us to get an idea how much this individual device contributes to the attack surface. This is what we have done in this table. And the metric that we're using is this last column right here. We call it the R-score or risk score. And this risk score is a combination of 3 factors. First of all, the V-score, which is all the CVSS base scores for all the vulnerabilities that affect this individual device summed up. Obviously, you're going to arrive at some number, which you see here. Okay. Then we also factor in the criticality of a device, which is assigned by an engineer. So an engineer can tell the OT security expert, well, actually this device is more critical than others. In our example, well, it's an engineering station for a very important piece of process control, or maybe even for safety equipment. And finally, we factor in a third piece here, which is the network exposure. In this particular case, it says public exposure. This means that we know that this device is talking to the public internet. It's internet facing, and we combine these 3 factors in order to show you, well, this is probably what you should mitigate first, because this device contributes heavily to your attack surface. Again, you can get all the details if you just do a double click. This also will tell you about the criticality, the exposure, any additional information, and you will see the security items, the security metrics also in this section right here. We see the patch history, we see all the vulnerabilities with known exploits, and again, if we uncheck this box, it will show you also those without known exploits. So this gives you another angle towards mitigation. The next and last thing that I want to show you is, which yet gives you another approach. This is a software-related table where we expose software products and how much they contribute to your vulnerabilities and to your attack surface. So these software products that are installed in our sample database are ranked by their CVSS base scores, summed up, cumulative, based on the actual systems that we have in our sample database. So we arrive at an indicator how much an individual software product contributes to our attack surface. And that would give us an excellent angle towards risk management, because by doing system hardening, we can now reduce our risk. And the benefit of system hardening is that it's much more sustainable as compared to patching. Because if you look at products like this here, Microsoft Windows 7, well, you cannot even patch it any longer, but even if you could, this product is carrying so many vulnerabilities that the radical solution to simply get rid of it by upgrading your systems to a new operating system version will go a long way. A similar example would be, well, Adobe products, Adobe Acrobat, Adobe Flash Player. This is what you see here. So you can use this table to get an idea, well, these products, would it probably be a better strategy rather than patching to just get rid of them? With Adobe Flash, that is almost a no-brainer, because in most scenarios in an OT environment, there is no good use case for Adobe Flash, but it used to be installed on various versions of Microsoft Windows. So if you just get rid of Adobe Flash, you already have done a lot for your OT security posture. And this is also reflected in the reports that I've mentioned earlier, so you can easily focus on those Adobe Flash vulnerabilities as we do here. You would see the affected devices, you would see which progress you have made already. So you see just recently somebody has removed Flash from a couple of systems, and therefore you see this little downwards trend here at the end of the timeline. Okay, so this is how that would look like. And there is a lot more to say about OT vulnerability management, but I just wanted to give you some pointers. Maybe to sum it all up, the bottom line is like this. You will be overwhelmed with vulnerabilities in OT. Once that you implement a serious OT asset management system that also exposes those vulnerabilities, you will be shocked. That's the natural reaction to those hundreds of thousands of vulnerabilities that all of a sudden are visible. You didn't see those before, because you were doing your vulnerability management manually. Now you're looking at hundreds of thousands of vulnerabilities. And this will make you realize rather quickly that you will never, ever be able to manually address that at first. So just forget about sifting through those CISA notifications or vendor notifications. Oh, there's a new vulnerability in those Rockwell products. Yeah, well, that doesn't help you to mitigate that specific vulnerability, because you're just looking at, not even at the tip of the iceberg, you're looking at a right? So you must understand the big picture. And once that you have done that, you can furnish a vulnerability management strategy that over time, and I'm talking about a couple of years, will help you to reduce, to melt that big iceberg, right? Over time, year by year, but then we're talking about thousands or tens of thousands of vulnerabilities year by year, rather than, oh, you know, that latest and most critical vulnerability that was beaten to death by the industry media, for example. That doesn't make any difference. The difference that you have to accomplish is to really melt that iceberg. And that is going to take a lot of time, and it all depends on a sustainable approach, on an efficient approach. In order to figure out what that approach might be for your organization with your specific infrastructure, you need these different pointers to see the big picture and to see the best opportunities for efficient mitigation. Thank you very much. If you want to understand what OTS means and what it is all about, it helps to go back in time and get an understanding of how that whole OT field actually evolved, how that digital OT, that networked OT came into being, how it got that importance that it enjoys right now. So it all started with the capability to process the data from your equipment, from your sensors, actuators, etc., that you could process all that information on computers. And certainly at a time when computers became considerably cheap. You are no longer talking about mainframe computers or those mini computers. So we are talking about personal computing, we were talking about networks. It was all about the process data. And that yielded a lot of value for the asset owners that they thought, well, fantastic, let's have more of that. And so they got more process data. And that continued to a point where we are now, where organizations struggle to actually understand what they got when it comes to the infrastructure. And that is the blind spot that OT asset management addresses. So the whole development of OT was always focusing on process data, on the content, if you will, in modern parlance, right? It was focusing on the content. And OT asset management, on the other hand, is focusing on infrastructure. Certainly, you need a proper infrastructure so that this content is reliable, it's accurate, it's timely, etc. Right? And that is the big divide or the big shift in your attention when you want to understand what OT asset management is really about. It's about your infrastructure that is made up of hardware, software, and networks. OT asset management does not focus on those transient data flows that go back and forth. So for asset management, that's an externality. Therefore, it also does not focus on anomaly detection. And that's another thing where it helps you if you apply this lens, where it helps you to separate OT asset management from ICS detection, as an example. You can clearly see that in the beginning of OT security as an industry, we saw that same mindset. We have to focus on data content. This is what anomaly detection is all about, right? But this is not what OT asset management is all about. In asset management, you focus on configurations. You focus on considerably static asset properties. You don't focus on data content. And for that reason, well, you are concerned with a very reliable and accurate determination of the various firmware versions that you have installed, the network topologies, etc. And now here is the interesting twist of events, I would say. You can make the argument that this focus on infrastructure gets you to a much better place when it comes to OT security, because now you can really focus on vulnerability mitigation, on long-term vulnerability mitigation. Since all of those CVEs, by the way, how many are there if you look at the present total of CVEs, it's roughly about 250,000, okay? No, that's quite a lot. So that gives attackers a lot of stuff to work with. And all of these, their importance, the question, are you affected by these CVEs or not? All of these can be answered just by looking at your infrastructure, period. You don't need to look at data content. It's all about the infrastructure and configuration. And this is what OT asset management brings to the table. So as opposed to focusing on the data that moves back and forth on the wire, that's a different area of OT security that we have focused on for much too long. So in other words, I could say that the same mistake was made as with OT as a whole, that users were obsessed with data content. And I mean, that's not a criticism, because certainly it was valuable. It was so valuable that this whole field exploded. But that is where the problem comes in, because all that development of OT and OT networks in factories, etc., was not properly governed. It was not properly planned. It was just done as yet another bolt-on extension of existing networks. It was done without any systematic planning. It was done without any risk management, if you will, right? So what would the consequences be? It was done without any change management. And that's the big issue that needs to be resolved today, because asset owners find themselves in a spot where they just totally lost track of what they have. So the fate of the enterprise is built on something that they no longer fully understand. That is the issue at hand, right? And why do they no longer understand that? Because the complexity just went totally overboard. Let's start with a very simple question. How many networks are we talking about in a typical manufacturing environment for, let's just say, a mid to large size factory? But it's certainly more than 5 or something that you would expect on the IT side. Let me tell you, usually it's a couple hundred. You didn't know that as the asset owner? Oh, sorry, or you should, right? And beyond that, you should exactly and specifically know what is connected to those networks. You should exactly know all the gateways, all the routing paths that are possible. You should exactly know about all the characteristics of these networks, their purpose, what are the endpoints in there for, right? What operating system versions are those endpoints running? Are those VFDs? Are those sensors? Are those Office PCs? What do you have? Well, guess what? Some asset owners are surprised when they introduce an asset management system. Oh, we didn't know, but we have so many networks we have never heard about, and then we have found PLCs on the enterprise network. That is a regular observation, and that gives you an idea about the overboarding complexity that has led to this scenario where asset owners completely lost track. And the bottom line is, this problem has become so big that there is no way that you could solve or even address that problem by using Microsoft Excel and a bunch of guys that you send around and they try to collect a manual asset inventory. It doesn't work, right? So this is where you definitely must use an automated OT asset management solution such as OTbase. This is what we're doing. This is what OT asset management is all about. It's about the capability to understand your OT infrastructure and also to assess if that infrastructure is configured properly in respect to OT security. So when you think about your attack surface, and also in respect to efficiency, in respect to maintainability. All of that comes into play because let's just say you have all those high-flying dreams about the digital transition and the Industry 4.0, but how would you ever be able to get there by simply bolting on another IoT device onto your existing networks? That's not going to cut it. So you must be able to furnish a strategy. And this is something that you can only do based on data. And the OT asset management system is that platform that yields this data.